Dear friends, engineers, consultants, and architects, once again, welcome to VK Jain Sir ki MEP classes. I am Professor VK Jain and will discuss the subject Early Streamer Emission Type Lightning Protection System. The Early Streamer Emission Lighting Protection System add an active element to traditional lighting protection. So there are two different type of technologies existing. An ESE lighting arrestor, also known as early streamer emission air tunnel, is a type of lightning rod that uses an electronic device to emit a controlled upward streamer towards an approaching lightning strike. This invites, in fact, lightning to fall at a particular moment. Early streamer emission technology enhances lightning protection by emitting an upward streamer before a lightning strikes, increasing the effective protection area compared to traditional system. Here are the key components of an ESE system. First one is ESE air terminal. This is the part mounted on the highest point of the structure. It looks like a pointed rod but has several features to initiate the upward streamer. This upward streamer is nothing but a impulse wave. These features can include multiple point corona rings or radioactive elements, though the latter are becoming less common due to safety concerns. Down conductor. This is the thick cable that carries the intercepted lightning strike current safely down to the grounding system. Grounding system means earthing system. Now, grounding system. This network of electrodes buried in the ground disperses the lightning strike energy into the earth. There may be optionally one control unit that include a control unit that monitors the system's functionality and may even have data logging capabilities. It may count the number of strikes also during a period. Dear friends, in this slide I have combined ESE system mounted upon a multi-storied building showing several components and make up material of all the upper portion, which is shown in larger view on top of the diagram and here also at the bottom. Now this is the multi-story building I am talking of, and this is the ESE terminal, item number 1. This is a part shown here. The item number 2 is a coupling method to downward conductor. Item number 3 is a mast. This one. Item 4 is a down conductor here. Item number 5 is the lightning incidence counter electronic device. Item number 6 is the inspection joint. Here you can open up the down conductor and measure the earth resistance here. 7 is the quadruple earthing assembly. This is the earthing set having 4 rods buried in the ground along with the number of number of salts. This has to be kept uh, watered during the year, during hard times. All outer body made of non-corrosive stainless steel of grade XL 304 grade, which provides acid run proofing during discharge. Dear friend, here I am describing how the ESE air terminal works. This is a diagram of a particular make. Uh, you have the lightning generated in the cloud, and at the stage number 1 the electrical lightning rod is shown. In the stage 2, storing energy from ambient electromagnetic field. This is ambient electromagnetic field, and it is storing like this. And in stage 3, formation of ionized path of the lightning discharge. This is ionized path and it is carried down. Dear friends, an effort has been made to show the coverage area for the lightning protection system, which may be calculated according to NFC 17102 of 2011. The coverage area falls under the umbrella shaped semicircle formed by the protection radius. Now you can imagine this is the building, and here is the lightning finial or lightning uh, arrestor, and it is mounted at a height of h, and it provides a semicircular coverage area to the complete building. The height of the ESE arrestor installed relative to surface and above the structure is a key factor for the making calculation. Dear friend, ESE lightning arresters are designed to provide a much larger active protection radius compared to traditional Franklin rods, with typical coverage ranging from 60 to 107 meter or more, depending on the model, installation, installation height, and safety level required. Key details regarding ESE model coverage include protection radius. The coverage is usually rated between 35 and 107 plus meters. Performance by level at a 5-meter installation height, model often covers between 79 meters level 1 and 107 up to level 4 as per NFC 17102 standards. The coverage area for the lighting protection system can be calculated according to NFC 17102 of 2011 year. The coverage area falls under the umbrella shaped semicircle formed by the protection radius. The height of the ESE arrestor installed relative to surface and above the structure is a key factor in this calculation. Friends, now I am to discuss working of early streamer emission devices. During a thunderstorm, जिसको हिंदी में कहते हैं बिजली का कड़कना, charge suppression occurs in the cloud. A step leader travels downward toward the ground. At the same time, object on the ground can launch upward streamer. When one of these streamers connect with the downward leader, the main lightning current flows. Typical working principle includes the ambient electric field increases as the storm approaches, as I have shown in previous slide. The ESE device senses this field through its geometry and internal components. A triggering mechanism generates a high voltage pulse at the tip. The pulse initiates an upward streamer current earlier than a simple rod, as compared to simple rod. The earlier connection may allow the ESC terminal to intercept the strike and take it downwards up to the earthing. The earlier emission time is usually expressed as a time advance, often in microseconds. Friends, different type of ESC technologies have been evolved during the period, of which the following are the types: electromechanical, second electrical, piezoelectric, and last is electronic. We'll be discussing only electronic. These different type of technology offer different level of efficiency. It was observed that electronic type offer the highest level of efficiency and reliability due to control aspect of streamer emission. Some ESE electronic systems were even tested on a real lighting condition, confirming to their ability to increase significantly the protection area. On the other hand, various features and accidents have been experienced with mechanical or electrical ESC air terminals. Friends, through this table, I have discussed the operating principle, internal components, claimed protection radius, standard acceptance, and maintenance. These all features have been compared with respect to conventional air rod or ESE terminal. Let me discuss that standard acceptance, widely accepted worldwide, accepted in some standard, debated in other. That is beauty of it. Maintenance, the conventional system requires minimal, whereas ESE requires periodic inspection. Friends, no international code or world over standard body recommend early streamer emission technology. Prominent organizations like the International Electromechanical Commission (IEC) and US National Fire Protection NFPA don't endorse ESE technology for lightning protection, uh, and instead they recommend conventional system. Only few countries are using ESE. Friends, in this tabular chart, I have shown relevant standards and codes for lightning protection systems. One major reason professionals search for what is early streamer emission is to understand its acceptance through standards. I have discussed, this is the French document which discusses, which recommends the adoption of early streamer technology and provides a design method. The international series focuses on conventional system, does not specify or endorse ESA. NFPA 780 United States also primarily addresses traditional systems.